Now. My name is Hongru Wang, and today I will share one of our recent works, TopicRefine, Joint Topic Prediction and Dialogue Response Generation for multi-turn and end-to-end dialogue system. And I will talk about this work from 4 aspects: the problem statement, our methodology, and experience, and then we reach our conclusions. The first one is the problem statement. So the topic problem we may focus is how to generate a topic-aware response to engage users. As we all may know, a multi-turn dialogue system always follow a topic thread. There are 2 examples in the figure 1. The left figure is a medical dataset, and the right figure is a movie recommendation dataset. As it is shown that both of these 2 datasets follow a topic thread, especially in the right figure. As we can find in this green part, the conversation starts from greeting, like the bird say, what are you up to? And the user say, I'm looking at the photo umbrella. I miss old days. And then the topic of this dialogue becomes miss. And then after several turns, then the topic shifts to childhood. And after and this processing go ahead, and the topic shifts at the discourse level of the conversation. So basically, this is our topic problem. We need to require the model to generate the topic-aware response. So follow the topic thread of the conversation. Then I will introduce 2 related works. The first related works is one of the representative works of this direction. So our previous works always formulate this problem as a pipeline system, like this target-guided open domain conversation. They first predict the keyword, and then select a keyword, just one keyword from a candidate keyword set. Like in this example, they select music, this keyword, and just context the conversation history and with the selected keyword. And by condition on these 2 information, they retrieve the response for the given conversation history. So the whole system is a pipeline, and they need to solve the first task, like keyword selection, and then solve the second task, response generation or response retrieval. This is one of our previous works. And also, our work is related to a retrieval augmented dialogue response generation. For example, given a query, maybe in dialogue system is a dialogue context. Given a dialogue context, the retrieval system need to retrieve corresponding similar context and its response. By retrieve the corresponding response, it just generate a scalar response like this one. Just delete some words or remove some words in the retrieved response. And then by condition on this coarse response and with the original dialogue context, the model is required to generate the final response. So here is the model generated response. Like I love the Iron Man too. I like watching Iron Man's comics. So as we can see, this processing is consists of 2 steps. The first step is to retrieve from a response from a large database, maybe a training data set. And then the second step is conditioned on the given dialogue context and retrieved response. The model is required to generate the final response. So This is a scaling to response dialogue generation guided by retrieval memory. So now I will introduce our methodology inspired by previous works I just talked. Our methodology solves these two tasks at the same time. The first task is topic prediction, and the second task is response generation. So basically, the first task is a classification task, and the second task is the generation task. So our challenge is how to generate a topic-aware response to engage users. So basically, we proposed a multi-task learning framework. Our framework consists of 3 modules. The first module is stage 1 response generation. Just like a conventional method, given the dialogue context and the speaker role threat and the previously topic threat, the model like GPT or any autoregressive model or any generation model to generate a response. We call this response from stage 1 module as a coarse response. It's not very good, maybe compared with the final response, like I just said again. This retrieval response is first cross response, and the final response is more the quality is better. So here, after stage 1 response generation, we got cross response. And then our second module is a topic prediction. And our topic prediction is a classification task. We use 2 variants to solve this task. The first one is BERT-based prediction. Because BERT is a bidirectional encoder, it have better capability at natural language understanding tasks. And also we can use GPT-based prediction. Because GPT has a multi-classification head, we also can use GPT to do understanding tasks also too. So the last module is stage 2, topic refinement. This module generates a refined response compared with a coarse response in stage 1. So the input of stage 2 is the coarse response in stage 1 and predict topic in module 2. So given the output from the last 2 modules, the final module need to generate the final response. So here is the architecture of our model. Our framework consists of 3 modules, like A, B, C. The A means stage 1, and B means topic prediction, and C means stage 2, topic refinement. So basically, A, we just first look at A, and the input is dialogue context, and the model maybe a GPT like a transformer decoder. It generates the first cross response here, using the LM head, language model head, generates the first cross response. And in second module, we have 2 variants, BERT and GPT. For BERT, we just use the CLS representation as the representation of a whole input or whole sentence. And use this embedding to do the classification. And for GPT backbone, we use the multi-classification head to the representation of multi-classification head to do the topic prediction. But here we just predict the topic is this topic in the next term. And for module C, stage 2 topic refinement, the input as we can see here, the blue line is came from the first cross response, and the yellow line comes from the predict topic. We contest the first cross response and the topic predict topic words, also with the dialogue history, the model then need to generate the final refined response. So similarly use the language model head. So this is our model. So basically our model firstly generate a cross response and use a topic, predict topic to refine the cross response. And at last we can get a more high quality and diversity response. And also it can attend on the predict topic compared with the first cross response. Because as we can see in, we do not introduce the predict topic information in the first cross response. So we hope the final refined response can attend on the topic more. Yeah. So let's move to the experience. We use two data sets to evaluate our proposed model. The first one is a medical data set, and the second one is a movie recommendation data set. Both of them are Chinese data sets, and medical data sets are task-oriented, and the later one is for recommendation system. As we can see, the dialogue is almost about 10,000 dialogues. The topic, one thing I want to clarify here is for the topic is the classification type of these two data sets is different. For medical data sets, the topic classification is a multi-label classification problem. Like you need to predict the topic is the topic we used in the nested or not, 1 or 0. For each topic, for example, if there are 10 topics, you need to predict 1 by 1, 1 and 0, used or not. But for the movie recommendation data set, the classification type is a multi-class. You just need to choose one topic from the given topic sets. For example, if we have 10 topics, we just pick one compared with a medical data set. Yeah. Here we I just quickly introduce the variants of our proposed framework. There are 4 variants in our proposed framework. The first one is Z1 GPT. This represents the first generated cross response, R1, and the stage 2 GPT stands for the refined final response, R2. And also, we just remove the refinement stage, like we do not want the C model in our figure, and we just jointly train the response generation and the topic prediction tasks. For example, A and B modules in the figure 2. For example, just we do not want the last step, and we just joint train the A and B modules by using a language model head and multi-classification head, using one single GPT model. Yeah, this we called GPT-2 double heads. Double heads means language model heads and multi-classification heads. And the last one is stage 2 BERT. We replace GPT with BERT only for B module in figure 2, because we think BERT has a better understanding ability compared with GPT. So if we use GPT, it will maybe introduce additional noise. So that will cause error propagation, because if you do not predict right topic in the second step in the model B, it's not guaranteed that you will get the good final response, because your topic is wrong. So the final response probably is not very good. So here we replace GPT with BERT. just for better topic prediction accuracy. Yeah. So we did our experience for 2 tasks. This is for generation task, response generation. So table 2 and table 3 shows the experimental result at 2 datasets. The table 2 is a medical dataset, MED-DG, and table 3 is TG retail dataset. As we can find, first of all, our variants, stage 2 GPT, stage 2 BERT, stage 1 GPT, and the GPT-2 double has. The performance, no matter in which dataset, as we can find the blue 1, blue 4, and here, blue 1, blue 2, blue 3. Our performance is higher than all baselines, especially previously SOTA in medical data is GPT-2 topic. GPT-2 topic just contests topic information with a dialogue context and predicts the response. Just one step to get the response. And the TG retail dataset is accompanied with the release of this dataset. The author of the dataset proposed a strong baseline, TGRG. This is previously SOTA. So compared with these baselines and SOTA, our model achieves a higher performance. And secondly, let's look deeper in our different variants. Like I said, first we can see the the stage 2 GPT, the performance is better than stage 1 GPT, no matter in which dataset. For example, this is 45, stage 2 GPT, this blue one is 45, and this stage 1 GPT is 43. And in TB retail dataset, the stage 2 GPT is 0.29, and the stage 1 GPT is 0.28. So we can find that stage 2 GPT is better than stage 1 GPT, which means our refinement is works, and it also demonstrates the effectiveness of the last step. And secondly, let's see the GPT-2 double has, the performance of GPT-2 double has and stage 1 GPT, like the last 2 rows in the table. So the GPT-2 double has achieves higher performance compared with stage 1 GPT, which means if we use multitask learning, like here we use topic prediction and response generation. We just we joint train the topic prediction and the response generation. So if the GPT-2 double has performance higher than stage 1 GPT, that means the joint training is effective. Yeah. Also, we want to say, as we can find the topic F1 and the topic F1 score of stage 2 BERT is much higher than other variances, which means the BERT did a better understanding, better in understanding task. And the next task is topic prediction task. As before, the table 5 and table 6 shows the performance at 2 different datasets. Table 5 is a medical dataset, and table 6 is a TG delta dataset. And we can find from the table BERT demonstrates more strong understanding ability than GPT model. Because as shown in table 5, BERT, the recall and F1 score is higher than stage 2 GPT. And in table 6, the hit at 1, no matter 1, 3, 5, the BERT demonstrates better performance compared with GPT. However, we can find the hit at 3 and hit at 5. The GPT, the gap between BERT and GPT is not very large as we think. So that's reverse the high understanding potential of a GPT model. Okay, and then we reach a conclusion. So first one, we propose a joint framework with topic refinement mechanism to solve the topic evaluation end-to-end dialog generation problem based on GPT-2 model. And secondly, we design a 3 paths. The first path is we pass the dialog context to get the first cross response. And 2 paths is we pass the dialog context to get the predict topic. And the third path is we pass the dialog context and generated first cross response and the predict topic to get the final. Sorry. To get the final refined response. So in this way, the final refined response is more informative and attend to the topic more. So we hope this topic aware response can engage the user more. So as a last, we validate the effectiveness of our model in 2 different datasets, medical dataset and the recommendation dataset. So that's all. Thank you very much. I'm looking forward to any questions.